So, good morning, everyone. My name is Filipp. I'm a part of SIGI Russian Geological Institute and also a participant of trilateral cooperation between Finland, Estonia, and Russian called ER55 or Adrian Project. And before the presentation, I want to say thank you to the conference committee, especially for being here offline. It's a great opportunity to present our results and share some new ideas. So thank you very much. And moving to the presentation, today's topic is in search of relations between factors of underwater landscapes in the Eastern Gulf of Finland using GIS and statistics. So briefly about the project, the aim of the Adrian project is to create a GIS portal where you can see the consequences of anthropogenic impact on the underwater landscapes ecosystem of the Gulf of Finland under various scenarios, including climate change. So doing monitoring and modeling on one hand, and also being in a cooperation with Finland and Estonia, we're searching for new ways to reduce the risks of human activity negative effects on biogeosynosis of the Gulf of Finland. On the slide you can see the example of a web page of the project's web page. So here the Sergeev depth is presented, and unfortunately yet the data of Russian site is not added, but we've got one more year to add our data, and after it in 2022 you can see the complex holistic picture of the parameters presented on the left. So we had 3 field seasons from 2019 to 2021, and I will talk about only 19 and 20 years because 21 year data is under the analysis now. So the spatial distribution of our points was based on, firstly, the multi-beam data when we had it. Secondly, it was based on lithological and thirdly, morphological aspects of the bottom. So we tried to highlight the main features of the Gulf and also to follow the idea of creating some kind of a net to have a complex map in the end. In 19 and 20 years, we did more than 300 stations, of which 200 was complex. By saying complex, I mean they were both biological data, geological data, physicochemical perimeters, and also we did underwater videos on most of the stations. Here you can see some of the pictures from the fieldwork processes and the features of the Gulf. So on the left bottom you can see the example of iron manganese concretions, and on the right some kind of ripples on the bottom, and the lonely Saduria in the bottom right. After that, we did the laboratory analysis and some kind of preliminary data processing. So firstly, from the geological side, we did the grain size analysis for each station. After it, some preliminary result processing, and the most important and the final step of the laboratory analysis and data processing was the creation of database for modeling, which included first physicochemical parameters like Sergeev depth, redox potential, hydrogen potential, and some other parameters, the type of bottom sediments, and of course the benthos parameters, including abundance and the biomass total and for each species. But why this topic of my presentation is important. So the desirable outcome of this work is the possibility of assessing and predicting the conditions of underwater landscapes using the relationship between biotic and abiotic components. So I think, yep, sorry, it's an old version of presentation, but okay. In some sense, the main outcome is some kind of bio or, on the other hand, geo indication. So if we know the correlation between perimeters, we can assess, for example, geological factors using biology and vice versa. And for now, the relationship between the spatial distribution of certain types of bottom sediments and benthos at the level of mesohabitat was not revealed. So it was a part of our investigation. And as I said before, we had biological data, geological data, physical-chemical perimeters, but what is very important is to have geomorphological features of the Gulf, and especially on the points we had. So to do this, we used the BTM. It stands for Benthic Terrain Modeler, an extension for ArcGIS. And this extension allowed us to create such a model which highlighted the main features of the Gulf related to the geomorphology. So on the slide, you can see the classification of mesorelief in the south part of the Eastern Gulf of Finland, including crests, slopes, flat, and depression. And a few words, how to say, like first steps towards the statistical analysis and the results of this, how to say, aim of our research. So firstly, using our big database for more than 300 stations, we did a data preparation. So we exclude some extreme values using 3 sigma rule, and also we assigned ranks to categorical values, for example, for bottom sediment types. So 1 for ferromanganese concretions, 2 for gravel, so it's a big particles, and 10 for clay for future statistical analysis. But unfortunately, when we're trying to do an explanatory analysis looking at the graphs and plots, we had no evident relations. And in some case, it is obvious because our data is not, how to say, it is a natural data, and it is very hard to have the normal distributed data in that way. But we did pairwise Spearman correlation, and fortunately, we had strong relationships between total abundance of macrozoobenthos and surface water redox potential. So the coefficient, as you can see, is pretty high. And also, we had some connection between biomass of macrozoobenthos and oxic bottom condition. There is some moderate relationships, including salinity and benthos distribution. So it was said before, and it was discovered before us, that there is a relation between salinity and the distribution of benthos. But unfortunately, which was our aim of the research, we had a weak relationship between abundance and biomass, and on the other hand, sediments and mesorelief types. So our first steps was not so successful because we did not find any straight relationship between abiotic and biotic components in the underwater landscapes. But along with the Spearman correlation, we did a simple linear regression, and we got the statistical significance in abundance and the type of sediments. So the p-value is pretty low, and it could say that there is a high potential for future investigations in this area. And also the multiple linear regression, which was done for abundance and the interruption of sediments and mesorelief types, also got us a nice result. So the p-value is pretty low too. Sorry, I had one more plot on the slide in the new version of presentation. We did the model assumption for the statistical significance of simple linear regression, and the QQ normal plot analysis showed us that this model is, it's fine, and vast majority of the points is straight on the line, so we should work on this model, but definitely we have some kind of connection between abiota and biotic components in the Gulf. And few words about our future plans and questions. We should add some more parameters in our model, including wave exposure, currents, and river runoffs. Maybe exact these parameters could influence our distributions, and maybe this is this could be a key role in modeling the connections between factors. Also, we had a 2021 field season, and we did more than 200 stations. Each of the stations was complex. So both biology, geology, physicochemical parameters, and we should run the model using this new data, but maybe better bathymetry resolution will be great for us for the Eastern Gulf of Finland, because now we have only 100 resolution data of bathymetry. And a small dream, it's detailed investigations. For example, it could be a Kurgalski reef. So here is the map for that kind of key area. Before that, I was talking about investigations on the mesorelief type, or on the mesorelief scale, sorry. But now it is very new to see and to look for the correlation on the small area. So very detailed investigations, and Kurgalski reef is a good key area. It could be a good area because firstly, we have a 3 meters resolution multi-beam data. Then we already have 9 stations of complex data. And thirdly, there is a high depth difference. So it could be very interesting to model it in the BTM. And we just need to make some new points on the slope, because it is very hard to get some samples from the slope, from the ship. So, but it could be very interesting to do. And the question is there any additional methods of GIS and non-parametric statistics which we can use to go forward in our not very easy, but I think very valuable investigations? Thank you for your attention. If you have any questions, please ask for them.
Thank you, Filipp.